Good night, everyone. Mechanics of Materials, Chapter 5, Torsion. In this example, we have a three solid cylindrical shafts with different diameters, like D1 is 5 inches, D2 is 10 inches, and the last one with the diameter of 15 inches. We want to, and it's fixed between two supports. We want to know what is the reaction at the fixed end TE. So we want to calculate the torsional torque at the second support. So let's see how we can approach this problem. And if G is provided for all of them is equal, and that's 11.5 10 to 6 pound square inches. And different torsional torque applied to different part of the length of the overall the combination. Let's see how we can approach this problem. We can solve it based off a first approach is because this is a indeterminate structure, we can release the support at E and apply a torsional torque there. We call that release and replace the support back in again. So let's see how we can approach it. We can release the support and apply the torsional torque DE, and based off that, if you remember, phi is TL over GJ, and because the original case has a fixed support here, we do know that phi is equal to 0. In that case, we can easily calculate by having this equation. The only unknown here is T at E, and we easily can calculate the unknown TE or unknown reaction. And in such case, phi of the other end is summation of TILI over GJ, because it's a combination of different discrete parts like 1, 2, 3, and so on. So in such case, if you jot down the equation for phi sub E, that's equal to summation of whatever part you have, and each of them is TILI, or G remains the same, and JI. So for example, for the first part, if you release the support here and apply TE, if you apply T here for and travel from right to left of the structure, you can easily see for this piece of length, you're only experiencing TE. So that's TL over GJ. And J is definitely half of pi C to the fourth, and C is the radius. And that's 7.5. G remains the same, that's a half of pi, 7.5 to the fourth. And move on for the other one. So J2 is half of pi, 5 to the fourth, and likewise J1 is equal to half of pi, 2.5 to the fourth. And that's only in terms of and that's the length for that piece. And when you enter to this part, if you make a cross section for this part of your structure, you're experiencing TE minus 750 pound-feet converted to inches, because the dimensions are in inches. So you have to subtract, and let's consider the direction of our TE, like this is the true direction. That's why TE minus, because it should be TE should be against the other. So TE minus 750 times 12, and the length of the other piece is 75. GJ, this is J2, this is J3, and plus when you are up to here, you have TE minus first minus second, which is 70 minus 7050 minus 8080 880. So this is like, let's have it this way. TE minus 70 plus times 880 is our plus. If you have it like, then you have the first one, second one, convert to inch time the length of that piece, which is 40 inches over here. And again, that's J1. This is J1. This is J1. Because we have a torque in the middle of the first part, we dissect it to two parts. So that's a 14 inch of length for the first part and the other 16 inch over here. And if you do so, it just gives you, and then phi e, in the original case, phi was equal to 0 because the support are fixed at both ends. So if phi is 0, the only unknown of our problem is calculation of torsional torque at the fixed end E. So in such case, it just simply gives you torsional torque at the fixed end E is equal to, that's our TE, and that's equal to 1911.84 pound-feet. We can also solve this problem in far simpler approach based off their torsional stiffness. I will do that in next video. Thank you.